Now we'll talk about the determination of specific charge of an electron using Thomson's method. So he is Mr. J.J. Thomson. In 1887, J.J. Thomson measured the specific charge of the cathode ray particles. The specific charge is defined as the charge per unit mass of the particle. Thomson discovered that the value of E divided by m charge that was independent of the gas used and also independent of nature of the electrodes. The main principle is the fact that the cathode ray electrons are deflected by electric and magnetic fields, and it is made use of a J.J. Thomson method of experimentation. You are able to see the cathode ray which is getting deflected through electric field. So the experimental arrangement is like you got an electrodes and this is your coil and you got your plate P1 and P2. And the electrode beam is coming here and this is your magnetic field and it's nothing but your fluorescent screen. Cathode rays are produced by the discharge between the cathode and the anodes D1 and D2. So the rays are passed from here to here and it is deflected by the magnetic field towards this direction or towards this direction. A thin pencil of cathode ray comes out through fine pinholes in the anode disc. The cathode ray then passed between two parallel metals P1 and P2 here between these two metals and strike the flat surface of the tube. The flat surface or face is coated with fluorescent material. A spot of light is produced here at Q, but when a potential difference V is applied between P1 and P2, the beam is deflected to point Q1. So this is how the arrangements are formed. Moving further, you are able to see by the use of a pair of coils here, a uniform magnetic field is produced perpendicular to the plane of the paper in this direction and outward towards the region between P1 and P2. If we talk about the determination of V with a given electric density or intensity between the plates P1 and P2, the magnetic induction B is adjusted until the beam strikes the screen at the original position Q. Then the downward force EE due to the electric field is balanced by the force BEV due to magnetic induction, where E is the charge of the cathode ray particle and V is the velocity of the cathode rays. So EE, the electric charge or downward force EE, is balanced by the BEV due to magnetic induction. And V is the velocity of the cathode ray. So equating your E and E here, you got E equal to B divided by V and V equal to E divided by B. This is your equation. Now we'll talk about the determination of E divided by M. So previously we have discussed about determination of V, the velocity of cathode rays. Now we'll talk about E divided by M. How we can determine? The magnetic induction is switched off now. We need to identify the charge, right? So magnetic induction is switched off. This is the first condition. The deflection is Q1 is equal to Y, which is caused by the electric field alone is measured. At the instant when the cathode ray enters the region between plates P1 and P2, the initial velocity in the downward direction is U is equal to 0. The acceleration along the downward direction A is equal to E divided by M, where M is the mass of each cathode ray particle. The time for which the electrons moves in the electric field T is equal to V divided by L. So L is the length of either of the plates and V is the velocity of the electron. So if you talk about determination of E divided by M, this is the formula. The deflection produced on the cathode ray along the downward direction is given by V equal to E divided by B, and the Y1. What do you mean Y1? Y1 is nothing but the distance here. So Y1 is equal to half EE divided by M into 1 divided by nu whole square. So substituting the value of V with E by B, you got half into EE divided by M L square divided by E square into B square. So tallying this E and E, you got half into E divided by M L square B square E, where V is the velocity, E is the electric field, B is the magnetic field, E is the downward force, L is the length, M is the mass, and E is the charge of cathode ray particle. Now we'll talk about further on the determination of charge. The displacement of the spot of light on the screen is given by Y is equal to K into Y1, where Y1 is here and your Y is here. Here the value K is constant and is determined by the geometry of the discharge tube. Substituting Y1 in this equation, where Y1 is equal to this one. Substituting this one, you got Y is equal to K into 1 by 2 E divided by M L square B square by E, where E divided by M is equal to 2 Y E and K L square B square. This is the charge of an electron. The above relation E divided by M of an electron can be calculated. The value of E by M calculated using this experiment was found to be 1.7592 into 10 power 11 coulomb per kilogram. The value of E divided by M of an electron can also be calculated by applying uniform magnetic field perpendicular to the path of the electron. So this is the important note you should understand.